So this is our lab report, our presentation. So my name is Amake Biama Aznan. So this is our lab report about error analysis. Okay, for sub experiment 1, we need to measure the copper wire using 1 meter ruler. So this is what we got from the experiment, and I'm just want to show how to calculate using Excel. So we use Excel to calculate the average, the deviation, the deviation, the standard deviation, and standard error. So this is the value that we got. Okay, for the discussion for part A, so this is the given data, and we must plot the graph from the given data. So for the error, we have a systematic error. So the calibration is observed in this experiment. The equipment that we use basically is calibrated in factory. So when we measured as a sample in the laboratory, so we can get we will get the different value. Hence, the calibration is no longer valid. So yeah, this is what we got, and yeah, this is end of part A.
Hello, Assalamualaikum and good day. I am Ali Izzati binti Muhammad Adnan and my metric number is 145642. I am the second presenter for the lab report error analysis. I'm going to present about part B. Here are the procedure. B.1, the data. The data that we get is from the reading of micrometer, and the number of sample is 320. The number of reading is n, and the ratio can be obtained from n divided by sample size. This is the histogram for ratio as the function of diameter using Microsoft Excel. We insert the data that we get and plot the graph using the Microsoft Excel to get smooth and nice graph. The Gauss curve is distributed to the right of the graph. From graph 3.1, the area under the curve that we get is 79 centimeters square. This is how we calculate the standard deviation, and the standard deviation that we obtain is 2.005 times 10 to the power of -2 millimeter. Next, determination of standard deviation from the equation. From the equation, the maximum value for the curve is 0.222, and based on the equation, we can get the standard deviation is 3.594 times 10 to the power of -6 millimeter. Here, we need to compare the result from method A and method B. Next, from the result in part A, the diameter of copper wire is 1.9 times 10 to the power of -4 meter, while the diameter of copper wire in part B is 195.65 to the power 10 to the power of 4 meter. Diameter of copper wire obtained in part B is higher than the diameter of copper wire in part A. Thus, the discrimination of value is significant. The standard resistivity obtained in part B is higher than the estimated resistivity from part A. The discrimination between the experimental value and standard resistivity value is significant. The percentage of error is 94.07%, and the value in part B is more accurate as the significant error is observed in part A but not in part B.